Hello, and welcome to episode. What are we on now? Just kidding, it's only episode 2. I can't pretend like we have a ton because it's number 2. Doesn't matter. So, today I want to delve into the periodic table. Now, I'm not going to go too in depth on the periodic table for now. I'll make another video on that, on the groups and periods, all that good stuff. But for now, we're just going to try to better understand and be able to, I like to say, read, quote unquote, read the periodic table. So it doesn't look like this big, intimidating poster of just a ton of stuff. Okay, that was poorly said, but whatever. Before we get into that, I want to thank our sponsor, Expo. You're not you when you're hungry. Eat Expo. Okay, let's get right into it. So, on the periodic table, I'm going to move this over here. So sorry. On the periodic table, we have a couple of things giving us information, right? And when you look at it, it's a little intimidating, but we're going to break it down step by step so you can better understand it, okay? So, first and foremost, if you look at a periodic table, you're going to see a number in the top middle, okay? Now, this is, I think, arguably the most important number that on the periodic table. And this is the atomic number, okay? Now, the atomic number tells us something very, very important about each and every element, and that is the number of protons. Okay? Now, I always tell my students this. This number for any given element is always going to be that number for that element. Now, what I mean by this is hydrogen will always, I can't stress it enough, always be number 1 on the periodic table. Okay? If you change this number, you are then changing the element, thus changing all of the characteristics of said element. Okay? So, for example, if I add a proton to hydrogen, I don't have hydrogen anymore. I now have 2 protons, which if we look on the periodic table is helium, number 2 on the periodic table over here. If I then throw another 10 protons on, number 12, now we're working with magnesium. We are not working with helium. Helium will always have 2 protons, hydrogen 1, lithium 3, so on. The number of protons dictates the element you are working with, okay? Don't forget. So, the atomic number, the number on the very top middle, is the number of protons, okay? And these have a +1 charge, okay? That's not super important right now, but I made another video if you want to go check it out. Subatomic particles, great video. So, this is the number of protons, and it never changes for an element, okay? Now, this H, pretty self-explanatory. It's the abbreviation for the element. Each element has its own name. Some make more sense than others. Hydrogen is H, makes sense. But then sodium is Na, which you're like, why isn't it just S? That's sulfur. A lot of it's from Latin backgrounds and who discovered it. For example, number 103 on the periodic table, Lawrencium. I looked that up before. I want to make sure I got it right, but that would have been cool if I had that off the top of my dome. Number 103 on the periodic table, Lawrencium, was named after, I believe, the university, Lawrence Institute. They discovered that element, so when you get farther down, names change to more like people or research groups, whatever that may be. But that doesn't really matter. So H for hydrogen, then we have the name, of course, hydrogen. Then this number down here is going to also tell us something very important, and that is the atomic mass. I also teach that in my other video. Just saying. Atomic mass. Now, we learned in episode 1 as well that protons have a mass of 1, neutrons have a mass of 1, and electrons have a mass, but it's so small that it's negligible. We just count it as 0. Okay? Now, if this hydrogen has 1 proton, 0 neutrons, and let's just say 0 electrons, doesn't matter, we should have an atomic mass of, well, 1 plus 0 plus 0, which we wouldn't even count the 0 for the electrons, but 1 plus 0 is 1, right? So where are we getting 1.008? That doesn't make any sense. Jake, what are you doing? Slow your roll, partner, okay? We're going to get into that right now. So this number, this atomic mass, is not 1 for a very, very cool scientific reason. And that is what is called, or what are called, isotopes. Okay, this is going to get a little more technical. Just bear with me. I'll slow her down, and we'll get there together. Okay, so isotopes, you can think of isotopes as elements, but variations of the element. So what do I mean by that? For example, hydrogen, and I swear we'll get there. Just give me some time. Okay, slow it down. Hydrogen has 3 isotopes: protium, deuterium, and tritium. And there may be more, but these are the 3 most common isotopes. Technically, you can keep adding, but we'll just stick with this. So these are 3 naturally occurring isotopes in the universe, okay? So protium is going to have 1 proton, 0 neutrons, and electrons we're not really worrying about right now, okay? So it's going to have 1 proton and 0 neutrons. Now protium, if we do our math, and I'll do a little key up here, we know protons have a mass of 1, an atomic mass of 1, and neutrons have an atomic mass of 1. So if we have 1 proton and 0 neutrons, 1 plus 0, you better have gotten that right, is 1. So protium has an atomic mass of 1, right? Now deuterium is a tad bit different. Now, remember, these are still all hydrogen. They're just variations of hydrogen, okay? So these are all hydrogen, but I'll show you what the difference is. Deuterium has 1 proton as well, because we know hydrogen always has to have 1 proton. If the atomic number is 1, it has 1 proton. Hydrogen will always have 1 proton, okay? So let's just finish tritium while we're at it too. We know tritium is also going to have 1 proton, because these are all hydrogen. Atomic number never changes for an atom, okay? But what we will change is the number of neutrons in this atom. So deuterium is going to have 1 proton, just like everything else, but it's also going to have 1 neutron. Okay, and that's what makes this different than protium. So now we're going to have an atomic mass of 2, because 1 proton, our key up here, 1 proton plus 1 neutron, atomic mass of 2. Okay, now I want you to try to fill the next one in. What do you think the next one's going to have? Tri refers to 3, D. You get the gist. Now, we know that it's going to have 1 proton, right? Because hydrogen always has 1 proton. These are all still hydrogen. They're just different variations of hydrogen. Tritium is going to have 2 neutrons, okay? Now, this, for tritium, will give us an atomic mass of, well, 1 proton plus 2 neutrons, atomic mass of 3. Now, I can't stress enough, these are all hydrogen. All hydrogen. Oh, my marker's cooked. All hydrogen. Okay, these are all hydrogen. They're just different variations because they have different numbers of neutrons. Okay, protium is going to have 1 proton, just like deuterium and tritium, but instead of 0 neutrons, deuterium is going to have 1, and tritium is going to have 2. Gives them an atomic mass of 3, 2, and 1. Okay, we'll do a different example. And before I get there, let's go back to what I was initially talking about. So you may be wondering, okay, so then why does hydrogen have an atomic mass of 1.008? Well, if we have 3 different kinds of hydrogen, 3 isotopes, how do I know which one's more important, or how do we get that mass? What we do is we do a mathematical calculation, which I'm not going to do here because there's a reason I majored in science and not math. What we're going to do is a mathematical calculation, and I can go into that into another video, but essentially you're going to take the abundance of each isotope and average them out. So for example, if we have a number super close to 1.008, or super close to 1, we know that the most common type of hydrogen found out in the universe is protium, because protium has an atomic mass of 1. Now, deuterium, which has an atomic mass of 2, and tritium, which has an atomic mass of 3, that's a terrible 2, they're still found out in the universe naturally occurring. We still find them. They're just so much more rare than protium that it barely brings up the average atomic mass. So remember that this number on each atom is the average atomic mass found in the universe, okay? So because this number is so close to 1, it's pretty safe to say that 99%, even higher, of naturally occurring hydrogen is protium, okay? Because that atomic mass is so close to 1. Now, for example, what if I changed it to 1.75? Well, now we find deuterium and tritium it's much more common to find those because our atomic mass is almost up to 2. So that deuterium and tritium is bringing our average up to I don't know why I got on my tiptoes, up to 1.75. But in reality, 1.008 is our average atomic mass because there's so much more protium compared to deuterium and tritium. Okay, now let's do another example. So we'll take nitrogen. Nitrogen is number 7. Let me get the average atomic mass, 14.007. So First and foremost, let's break it down. Let's read it like we've already learned. 7, as we learned from hydrogen, is our atomic number, okay? Atomic number. Now this tells us what? Don't screw it up or I'm going to be really disappointed. Number of protons, okay? So we know that nitrogen has 7 protons. Now, can it have 8? No. Can it have 6? No. Can it have 9? No. It will always, always, always have 7, no matter what. If you don't have 7, then you don't have nitrogen. Simple as that, okay? Now, what we can also do is we can say, okay, 14.007, let's just call it 14. It's so close to 14 that we'll just call it 14 for the sake of this little quiz. So, if we know that it has a mass of 14, like I said, I know it's a little higher, but we'll just call it 14, and we know it has 7 protons, and we know from watching episode 1 of Molecular Mindset that 1 proton has an atomic mass of 1, well, let's just do some simple math. 14 minus 7 is 7, right? Now, how many neutrons must I have if I have 7 protons and my mass is 14? 7, right? 7 and 7 equals 14. But Jake, what about the electrons? There might be, 7 electrons, let's say. Remember, electrons have such a small mass that we don't count them. It's negligible. It's not worth our time. They're so small that we don't count them in mass. We only count the protons and neutrons. So, if you already know that there's 7 protons, you can easily get the mass, okay? Now, there are different isotopes of nitrogen that have different numbers of neutrons, which doesn't change what atom we're working with. It's still going to be nitrogen, but it will change the number of neutrons, okay? So now we're going to do a full quiz. I'm going to make this up on the fly. Let's do carbon. Okay, carbon. It's number 6 on the periodic table. I believe it's 12.01. Yeah, 12.011. Now, how many protons do we have in carbon? 6, right? Our atomic number is 6, so we have 6 protons. We'll always have 6 protons when working with carbon. Our atomic mass is 12.011, right? So, most of the time, we're going to be working with carbon that has 6 protons and 6 neutrons. Now, what if I told you to find, before we do that actually, the different isotopes of carbon are carbon 12, carbon 13, and carbon 14. And that little number just tells you the mass. So for example, carbon 12. We just did that one. Carbon 12, they're all going to have how many protons? They're all going to have 6 protons. They have to all have 6 because they're all carbon, right? But what number does change? The number of neutrons, right? So carbon 12 has a mass of 12. And if we have 6 protons, well, 12 minus 6 equals 6. So if we have 12, mass of 12, 6 protons, carbon 12 must have 6 neutrons, right? Now if we have carbon 13, this changes a little bit, right? We know that we have 6 protons. Carbon always has 6 protons, okay? But in this case, we have an atomic mass of 13. Well, if carbon 12 has 6 protons and 6 neutrons, and that equals 12, of course, and carbon 13 has 6 protons as well, because it has to have 6, there's only one factor we can change, and that is the number of neutrons. So carbon 13 must have 7 neutrons. Now finally, I want you to do this on your own. I'll pause for 2 seconds. Boom, we're back at it. Carbon 14, we know it has a mass of 14, right? And we know that carbon always has 6 protons. So if we do the simple calculation, 14, the mass, minus 6, the protons, is going to give us the number of neutrons. Okay? And if you do this math, you're going to get 8. So carbon 14 has 6 protons and 8 neutrons. I hope this helped. Like I said, this is a pretty simple kind of overview of the periodic table, how to read it. So we know that the top middle number is the atomic number. That's your number of protons. That will never change. The letter is just the abbreviation. And then our atomic mass, right, is an average of all of the isotopes that we find. And we know that isotopes are the same element, but with a different number of neutrons. They're variations of the same element, okay? So for example, carbon 12 is always going to have 6 protons, just like carbon 13, 14, but that 12, 13, 14 is our mass, that will have a different number of neutrons, because you can never change the number of protons in an atom. And electrons we don't care about because they're losers. Their mass is negligible. I hope this helped. Please let me know what I can do better to make these videos better. I'm having a lot of fun making these, so I hope they help you. And get back to studying because you keep procrastinating. Take care, and bye-bye.